Hello, this is a tutorial for the program Simpleware. We're going to be looking at the conversion of an MRI scan of arteries around the heart into a 3D model ready for exportation to a CFD program. This tutorial is going to be using the tutorial files supplied by Simpleware. So if you go to open and then navigate to the installation directory of Simpleware, so for me it's program files, Simpleware, data, and then bloodflow. I want to open up bloodflow.zip. Here is the raw MRI scan data, so we have 3 2D slice views and also a 3D model view down here. If we go to the View tab, you can turn the slice cursors on and off by clicking it here. We'll leave them on for the moment. And also make sure the orientation is set to medical. And you can also turn the background light on and off. We'll leave it off for the moment. In order to get a better visual representation, if we expand the 3D model view, we can add a volume rendering preset. So go to the settings, presets, and then we want to select MIP Rainbow. If we load that one up, we can also change the opacity down to about 600 and also bring the green down to 600 and also bring the red down to about 650. You can now clearly see the arteries within the model. Next, we want to segment the arteries away from the rest of the model. So minimize the 3D view. We can create a new mask by double clicking on the masks down here. And then we're going to use a density threshold to segment the arteries from the rest of the model. So click threshold. Enable the interactive threshold. Make sure this is to replace the mask and also perform on all slices. To know what range of values to use, we can use the profile line calibration tool. This shows the density grayscale values across a profile line. So if we change this 2D slice to a visible artery, say for example slice 52 here, we can see an artery. Draw a line from here and here, we have the grayscale values across the line, and this hill in the graph represents the artery. So we know that the grayscale values for this artery are around this level here. We can also bring the line down here to change the range of the density threshold. So for this, range of about 266 to the maximum of 1336 should be good. Apply that. Next, you want to use the flood fill to create one continuous model. So if we select flood fill, we want to apply from the active mask 3D mode, replace with mask, and perform on all slices. And then we can click on a pixel from the artery, so for example this one here, and that will apply the flood fill. In order to see the model, we can enlarge the 3D model view and then refresh. And here is our rough model that we've just created. We've seen that we need to do quite a lot of cleaning up of the model. So first of all, we can crop it. So if you go to Transforms, Crop, in the Y direction, we can change the lower boundary to 150 and the upper boundary to about 360. And you can see the new crop view here, but this new box. OK for that, and then refresh the model again. This is what we're left with. Next, we can smooth the model. We're going to use a Gaussian smoothing. So if we click this on the smoothing tab, we're going to apply on the active mask. Make sure binarize is ticked. And we're going to use values of 1.6 for all of these. So we can apply this smoothing, and if you refresh the model, you can see here it's smoothed the model quite nicely. Because the smoothing will disconnect some small features, we need to reapply the flood fill to ensure we have one continuous mask. So again, select flood fill and click on the part of the arteries. And you can see here that it's removed some parts of the model that weren't connected. Next, we want to remove some unwanted parts of the 3D model. For example, we don't really want this part over here. And because it wasn't removed in the flood fill, this means it's got a small connection somewhere. And we can see if we zoom in, there is a small connection just here. One way of removing this is to use the paint tool. Here you can unpaint parts of 2D slices. So to do this, we need to navigate this part here on all the 2D slices. A quick way to do this is to hold your cursor over this part here and then press P on your keyboard. And you can see that all the 2D slices have snapped to this position. So if we go to Segmentation and Paint, brush settings, we can use Disk, use a smaller size of 1, and we want to unpaint on the active slice. If we zoom in on this 2D slice here, this is the section we want to remove. To zoom in, hold Control and use your mouse wheel to zoom in. And we can literally just unpaint this section here that we don't want. And it's got rid of it. And to see this better, this is the part we didn't want, and if we refresh this view now, you can see that this bit has been removed. We can now use the flood fill again to remove this portion of the model. So select flood fill, select part of the arteries, I'm back to slice 52 for this one, select here, and now we can refresh this, and this part of the model has now been removed. So now we're going to crop the model again in order to gain flat sides for this part of the model here and also this side part. So we go to Transforms Crop, change the X lower boundary to 10 and also the ZF boundary to 75. You can see it's brought in this section and also brought in this section here, so OK that one. Refresh the model and we can see that we've got a nice flat side here and here now as well. So our model is now ready for meshing for CFD analysis. So before we do that, if we want to save it as a new file, so go File, Save As, and save it as something else. I won't do it here because I'm just using this as a tutorial. So now we want to mesh the model and set it up for exportation to a CFD program. So first of all, if we rename our mask by right-clicking on it, rename, let's call it blood. We can then add a CFD model by right-clicking on models and click on create a new CFD model. Drag and drop the blood mask to model 2, and that adds that mask to the CFD model. We can then go to the CFD model tab up here and then go to model setup. Here you can change all the settings for the CFD model. Export type, I'm going to use open foam volume. It's a CFD model, that's all fine. I'm going to leave the general settings as they are. The volume meshing, I'm going to change the compound coarseness of the mesh to -15. Leave this as FE free. And then the boundary conditions from blood, these are the boundary conditions from where this white box cuts the model mask. So you can see here we've got a Y max down here from this axis and there's a Y min down here. But say what if we wanted to add an outlet boundary condition here, for example. To do this we can add or manage clipping planes. So click on that, rotate our model to get a nice front view, and then click on the plane here, then click and drag to make a plane, and then using these circles you can rotate it. So I'm just going to make it quite rough here, and then also need to rotate it down a bit, like so. There you go, that looks pretty good. So I'll add that one, which is Commander Finite Plane 1. I'll add another one on the other side. So let's say, for example, here. And again, just rotate it easily, like so. And bring it down a bit. There you go, that looks pretty good as well. So we'll add that one. So now we can add these two, add a boundary, and because in OpenFOAM you specify it within the actual code, I'm just going to call it a generic patch. And also for this one, I'll add that boundary as a generic patch. And also all over boundaries, so what else do we need? We've got these two. We need the Y max, so I'll add that one. Also need Y min, add that one. And also we need the Z max as well. So Z max, we'll add that one. We don't need the X ones because they're included in the finite planes. Boundaries that aren't summarized here are automatically just given the wall boundary conditions, so we don't need to worry about the background interior. So if we go to mesh refinement, we can leave this, and boundary layers, we can leave this as well. So we close the settings now and tell it to generate the full model mesh. Give it some time to do this. Okay, so mesh generation is successful, which is always nice. And here is our generated mesh. If we go to view, I'm going to turn off the background light quickly to get a better view of it. You can see here it's generated the mesh quite nicely. You can also check the mesh statistics in the log tab here. And you also have the important things like the tetrahedral volume skew. We've got no elements of greater than 0.99, which is nice. All of the information is here for you to have a look at. Go back to the document. If you want to have a look at just what boundary conditions we've got, go to visibility options, click on blood mask and go to service entities, change the boundary conditions. Here you can see all our specified boundary outlets and inlets that we will change within the OpenFOAM code. In order to export the mesh, go back to CFD model, and then go export, and you can select a folder to save all the files needed by OpenFOAM to run the simulation. All you need to do is just drag and drop the files created by this exportation into the polymesh file. Okay, and that's the end of this tutorial. Thank you very much for watching.